Okay, here we want to see how to solve a linear system using a matrix. We have to set up a matrix because we want to solve for x, y, and z simultaneously. We want to solve for all three variables. So now what we do, we take this linear system and we turn it into an augmented matrix. 0, 2, 3, 8, 2, 3, 1, 5, 1, -1, -2, and -5. All right. We got this augmented matrix from the coefficients here. So now, you have a lot of freedom right here. But what I like to do personally, I like to start with my ones if possible at the top left and push myself down and then solve my way back up. And you'll see what I mean. So now, I want to switch row 1 and row 3. All right, so I have 1, -1, -2, and -5. 2, 3, 1, 5, and 0, 2, 3, 8. All right, so I did nothing but switch my row 1 and my row 3. That's part of our elementary row operations. So now I want to work and push myself down so that I can back substitute myself back up. So we're going to our next step. We have a +1 and a 2. We want this a 0. We want to say -2 row 1 plus row 2 to give us a new row 2. All right? Because we're only affecting row 2. So now, we have to have a lot of mental math here. 1 times -2 is -2 plus 2 is 0. -1 times -2 is 2 plus 3 is 5. -2 times -2 is 4 plus 1, which is 5. And -2 times -5 is 10 plus 5, which is 15. All right, we're one step closer. Yeah, there are a couple of things that we could do right here to create a 1. We could say -2 row 3 plus row 2. That would give us a 1. We could say -3 row 3 plus row 2. That would give us a -1. Or we could multiply by 1/5. That's what I'm going to do. But like we say, you have a lot of freedom to work within these problems. All right. So now we say 1/5 times row 2. All right, we have 0, 1, 1, 3, 0, 2, 3, 8. Now we can start seeing it coming forward a little bit. Now we have zeros in the correct position, and we need a 0 right here. That's what's going to give us row echelon form. So how do we create a 0 from this one? -2 row 2 plus row 3 to give us a row 3. -2 times 1 is -2 plus 2 is 0. -2 times 1 is -2 plus 3 is 1. And -2 times 3 is -6 plus 8, which is 2. Now, we have row echelon form. All right? We have that triangular matrix that we're looking for. So now, we've pushed ourselves down so we can back substitute ourselves back up. 0x plus 0y. 0 is equal, z is equal to 2. 0x, y plus z is equal to 3. But we've already concluded that z is equal to 2. Y plus 2 is equal to 3, so y is equal to 1. So now we say x minus y minus 2z is equal to -5. X minus 1, what's 2 times z? minus 4 is equal to negative 5. X minus 5 is equal to negative 5. We solve this one. X is equal to 0. All right. So now we have what for our solution? 0, 1, 2. And we can easily go back through and solve everything and make sure it would work. We would have 0x, 2 plus 6 would be equal to 8, and we can back substitute all the way. We have a lot of freedom within these problems, but our answer will still be unique. All right. So don't get married to a method for doing these problems. Give yourself the freedom to work within these problems. There are several different ways, but what I like to do personally is just to start up with a 1, push myself down, all right, and back substitute ourselves back up. And that's how we solve just a linear system where we solve simultaneously for x, y, and z.